we're going to be talking about two major game-changing features, resource class and parallelism at CircleCI, and how we can use those two. We invited you here on the webinar today more specifically because you're either the power user at your organization, you're invested in the relationship with CircleCI, and or you're really interested in hearing more about what we've got to say. And more to add to that is there could be, your organization's currently using CircleCI, and there is a potential for credits to be burned at your organization, right? So check in with your admin to see if there is that wiggle room when it comes to credit consumption. But you were invited today because we've done a little bit of research. We understand that there is a little bit of gap there to close, and we'd love to demonstrate two different ways you can optimize for speed and value to sort of close that gap a little bit more, right? And obviously check in with your account executive at CircleCI if no one on your team knows about any of that stuff at all. Sweet. So I already mentioned the two features we're going to be talking about. As I move forward here with my slide, here is the agenda. So before I get to my example and hypothetical example to sort of demonstrate the concepts here, I've got a few slides around our Insights UI. I'll obviously want to, sorry, I should have mentioned one. I'll tell you a little bit about myself, what I do here on a day-to-day basis. Then I'll go through the Insights UI. I've got slides on that where you can really click into there, use that tool. We'll introduce the two concepts, how to solve for speed and how to solve for value. Using an example, I'll break that down more specifically on how CircleCI features can help your organization leverage both of those gains. And then ideally after this session, you'll be able to look into your project's executor choices within your YAML config and better understand if a change in resource class or parallelism could improve your test suite or build duration, right? And workflows, right? Improve your workflow duration and cost overall. So that is the end state that we're looking to get after today's conversation. So hopefully we get to that place. A little bit about myself. I'm a technical success manager at CircleCI, and our main role here as technical success managers is to help customers with onboarding, utilization, and overall guidance around the tool itself, right? We work day to day with customers like yourselves on these specific things, and this is sort of a snippet into what we'd like to highlight and chat through with organizations. So I've been here for over 2.5 years at CircleCI. I live in Denver, Colorado, originally from New York City. Went to CU Boulder and then just never left. And a fun fact about me is I really love soccer, big into the Premier League, and I love playing video games as well. Sweet. So enough about myself. A little bit more on why you're here, right? So this first slide here is a snippet of our CircleCI dashboard, right? As a developer, when you're committing code, you are running pipelines on our tool. This is your main hub day to day, right? And if you're not familiar with this slide, maybe you should be, but it's definitely the jumping off point for all things CircleCI when it comes to our UI, right? You can see that you can sort the pipelines. You can have, there's drop downs around branch, there's drop downs around project, and those allow you to filter in to see more granular data around your CircleCI pipelines. So lastly, the only thing I wanted to highlight on this screen, if you're not too familiar with it, is that you are able to perform certain actions on this as well. Rerunning the build, SSHing into it, for example. And so this is our hub for the UI, has been for years and years and years. But more importantly, I wanted to bring attention to the Insights tab right here. You can see the arrow. This Insights tab is a couple of years old. And the Insights page is the tool we want to use to help us better understand if the two features that we're suggesting you use later on are important to specific projects and workflows within your organization. So I'm going to go ahead and click on that Insights tab, and I can see a little page or two screenshots of a page here, which are my Insights homepage, right? Here is the homepage where you're going to see aggregated data around all of your CircleCI pipelines, right? consumption data around credits, duration, overall pipelines running, and then success rate as well, right? How often are these builds passing, right? And we're getting an exit code of 0, right? So taking a step back here, as an organization, are you looking at this page regularly, right? I want to understand, are you monitoring CircleCI trends? Do you have CI goals? If so, this is going to be the place to go, right? And areas that we recommend you look at to potentially track and monitor your builds metrics, right? So, overall questions you should be asking yourself rhetorically in the back of your mind as you see this are, what are your team CircleCI goals? Who is responsible for tracking these? And what metrics do I really want to pull out of my builds that are really actionable and useful moving forward? So on this Insights homepage for today's exercise, we want to know what we're going to look at. And I think the easiest place to look is going to be the highest credits consuming workflow. So if you're on this page and you're following along with me currently, I'm just going to click on the highest credit consuming workflow, which is just our CircleCI playground setup workflow here. Sweet. So when I click on that, I'm expanded to see all the most recent runs, right? And this is all about setup data specifically, just this one workflow itself, right? Here you're going to see some more granular data around total workflow runs, the success rate of them, the duration of them, how many credits that's actually consuming per run, the mean time to recovery, so when a red build goes green, and then the throughput, which is just the daily runs on average, how many times this workflow is running daily, right? So I'm really showing you all of this Insights UI to give you a place to start, right? We want this to we're clicking here to better understand the overall pipeline duration and metrics, and understand this is where we're going to start off when we're sort of planning on using these two features that we're going to later talk about. So as we're moving along here, we'll want to click on the most recent run. So just to get a better sense of the optimization efforts and the CPU usage, right? So I'm going to go ahead and click on this most recent run, and it's going to bring me here. And a quick note as well, you can definitely see all the job data in aggregate as well for that workflow, as well as if you're collecting test data, you can also see that data in aggregate as well. But for today's purposes, we're just going to click into that most recent successful workflow run, and you're going to be brought to this screen, right? And so this screen is where you can see more specifically the steps and jobs within that workflow itself, right? So you can see some passed, some failed, and this is really important here because we're going to want to identify a specific build job here. As you can see, older code job in workflow A, and we're going to click on that, and it's going to bring us to this screen behind, right? So clicking into this job, as I just mentioned, clicking into this older code job brings us to this screen behind us, which has a list of all the steps within that job. So when we click into that, we'll see obviously the steps within that job. And for today's purposes, I really wanted to bring your attention to the resources tab within a specific step, right? Where that second arrow is right here. This tab is really important to track your executor CPU and RAM utilization rates, right? So I'm going to go ahead and click on that, and it's going to bring me to this page right here. So this is the virtual machine's compute power and CPU and RAM graph. I've actually just sort of highlighted the CPU here today. The reason why I'm demonstrating this is because this is how we identify if the executor size choice is correct for our organization or not. More specifically, if this is correct for this specific job or not, right? So from a value and speed perspective, this is where we want users to come to within the UI to see and monitor and track the overall CPU usage of this specific job, right? So just wanted to see, and sort of a question to ask yourselves in the back of your mind as you're going through this, maybe with your own organization, is is my CPU being exhausted here? The answer is no. The answer is yes, it is. It is being exhausted. Sweet. So what we recommend, right? So from a CircleCI perspective, every organization is going to be different, right? But there are some overarching guidances we can provide. And so when we're thinking about looking at speeding up our builds, these are going to be some general rules of thumb we want to follow when setting up our project, right? So compute heavy build jobs, right, should be much larger. We're talking XL resources, 2XL, large and above, right? Because typically we're doing simulations on them, front-end tests, things of that nature, right? The smaller executors are really designed for pinging endpoints, health checks, and overall code coverage, right? I think that is where we, generally recommend you start when picking a proper executor for your job. This choice here is really important because we can uncover blind spots without even realizing, right? Overall, there's going to be a default executor choice for your organization, but as we set up our project, we want to predefine these executors to ultimately understand and limit any CPU spikes that could occur right before they happen. Obviously, you could experience some degradation if you're not properly choosing the right executor choice. Sweet. So I've got a hypothetical example I want to walk through, but before we get into that, I've got 2 slides to sort of maybe answer some questions that may be coming up in your head around this prior, right? So I wanted to highlight a feature called matrix jobs, which allows you to write in your config multiple arguments around different executor size, right? You can do it with both operating system and then with executor size as well, right? So matrix jobs could help you solve for running the same job on different instance sizes to better assess which executor you'd like to use moving forward, right? This would be a lot in pre-planning stages, but definitely a good tool to map out multiple executors. And so definitely want to highlight this feature as well. The second thing is why executor choice matters. And ultimately, I wanted to boil that down into 2, one really core issue and then one larger issue, right? The core issue is that, these resources are virtual machines, and ultimately there are memory limitations should you throttle and, ultimately max out the machine that you're using to run your builds on, right? So out of memory could be one of those things that limit your builds ultimately make sure, or ultimately, how do I say this? Like prolong your workflow from running in a proper manner, right? So monitoring our Insights UI, looking at the resource class tab regularly and understanding if the VM is being maxed out is going to be really key to determine whether or not you're making the right choice from a resource class size perspective. Right? Secondly, is just cost and value, right? So if there are simple changes you can make to your config that aren't costing your organization any money whatsoever and only saving your engineers time, you're going to be a hero, right? When it comes to your DevOps team and your peers, right? And engineer around you and engineering, right? Overall, performance is key. Developer time is key. And so improving that efficiency and limiting the exhaust that is going on is going to be very important for you to look at when it comes to designing and picking your right executor. So definitely want to highlight that. And I've got a little link in here as well, so you can understand how to record a memory usage as well. Sweet. So optimizing overall, right? What does that mean? And looking at speed and value together. So the next few slides, I'm going to take a single container workflow. We're going to mess with resource class size and parallelism and understand what that looks like for organization from a cost and speed perspective. One thing to note, this is a little bit dated, the resource class by default is actually going to be large now. That won't matter for this example, but I did want to just highlight that on today's conversation. Sweet. So Here you can see a single container workflow, right? It's a job that builds an application, runs a few quality assurance tests, and then reports back to a deploy step, and pushes the application elsewhere, right? So on average, running this pipeline with some basic assumptions, it's taking just under 30 minutes, hypothetically 28 minutes. As you can see, the test cases are a bit long. So my goal today is to suggest two things, right? We're going to suggest parallelism, right? So we're going to break up these test cases, and then we're also going to toy with the resource class size to see how we can improve this workflow's duration. So the first thing we're going to begin with is adding multiple parallel containers to parts of our test cases. So here you can see that if we run test cases in parallel, right, we're going to run the build step, pre-compiling any of our assets, right, that we need to run these tests for. And then we're going to run tests 1 and 2 in parallel simultaneously. So waiting for the 6 minutes to complete, then test the test 3, right? That test case is 3. We split up into 3 different components. Breaking those up allows us to run 3B and 3C in parallel. And so by doing all of this, we're able to save about 6 minutes, right, on this overall workflow. You can see that just by parallelizing our test suite, you can save time directly. So hopefully we're doing this across the board, right? Test jobs in general, from a CircleCI perspective, we highly recommend you add parallelism to, at least a key of 2, right? Just to see, some key and time saved there, right? But if we also toy with our executor choice, as I show you here, we can actually take that entire 28-minute workflow and bring it down to just around 7 minutes. So more specifically, and on the slide, it illustrates it really well, you can see that if we mess with the different executors, right here, by default, we had a medium build job, and then we increased our test case 1 and test case 2 to a large and medium plus. And then our 3A, we changed that to an extra large container. 3B, we made that a medium plus. 3C, we made it a medium plus. And then our deploy job, we made a small container. We took that 20+ minute workflow and we brought that down to just a little over 7 minutes. So really powerful stuff. And if this isn't being considered at your organization right now, we definitely recommend you look at these 2 really basic keys within your YAML config and better assess if there is an opportunity for you to add parallelism and hopefully upsize your resource class, right? One thing to note too, right? Since we're taking this workflow duration from 28 minutes down to 7 minutes, actually on a hypothetical example, we're saving $17 per run because the executors aren't running for as long. So we're not only decreasing the workflow duration, but we're actually saving our organization money on a per workflow basis as well. So not only do we optimize for speed, we also saved our organization money as well. Question rhetorically, obviously, for everyone is, are there pipelines that can benefit from this at your organization? I bet there could. All right, lastly, just to bring this home, right? If we take an average software engineer's salary, right, and we look at them, their cost per minute, it's about 83 cents per minute. Assuming they work 40 hours per week every year, a CircleCI extra large container only costs you about 2.4 cents per minute, right? So we're just mapping each time there. That means running 34 extra large containers on CircleCI is going to be less expensive than a developer waiting an extra minute for a test or build to run. So if adding 34 extra large containers to one of your workflows just saves one developer 1 minute to complete, you're generating value for your organization. Overall, I'm hopeful that if you look at resource class sizes on CircleCI and adding parallelism to your organization, you're going to be able to iterate faster, push code faster, and overall just reduce waste for your organization. So that is going to be it for the content on my participation. I hope you got a lot out of walking through the Insights dashboard, where you can farm this data, understand what your CPU utilization rates look like, and then hypothetically look at any of your workflows and see if adding parallelism or upsizing in your resource class could benefit your organization, save them time, and actually save your developers some money as well.